Hey guys, welcome back. In the last few lessons, we saw how to set up a cluster. And as you saw, it took some time and effort to install and configure a Hadoop cluster. Forget about the time and effort involved in setting up a cluster for a minute. Let's say you work in a startup and you don't have the need to run MapReduce jobs all the time. But occasionally, that is maybe once a day or just once or twice a week, you have the need to run MapReduce jobs against your dataset. In such cases, there is no point running a Hadoop cluster all the time, correct? Because this is a huge waste of money. To make things interesting, let's say you need to occasionally run MapReduce jobs, but when you do have a need, you need to run a MapReduce job against a 100-node Hadoop cluster. Because you have a big dataset and you would like to process the dataset in short amount of time. Maintaining a 100-node cluster is not an easy task for a startup. It takes up a lot of time, money, and effort. And the money, time, and effort spent does not justify the occasional usage of the cluster. So what is the solution? Amazon offers a solution and it is called Elastic MapReduce, or in short, EMR. Using Elastic MapReduce, you can start a Hadoop cluster in a matter of minutes, execute your MapReduce jobs, and terminate the cluster once you're done. It's like having a Hadoop use and throw cluster at your fingertips. The true power of Elastic MapReduce is, as the name suggests, it is truly elastic. Meaning, today, let's say you want to run your job against a 100-node cluster, and tomorrow you want to run your same job against a 10-node cluster. Or let's say you started your job on a 20-node cluster, but now you want to resize the cluster to 80 nodes. It is all possible with EMR. When we install Hadoop in our previous lessons, we used EC2 or Elastic Cloud Compute instances to install and configure Hadoop. An EC2 instance is nothing but a node with a CPU, hard disk, and RAM. When you request EMR to run a 100-node cluster, EMR will bring up 100 EC2 instances and install and configure Hadoop on those 100 instances for you. EMR offers two Hadoop distributions to choose from. You can either choose Amazon's version of Hadoop or Hadoop distribution from MapR. EMR does not support Cloudera or Hortonworks. Along with Hadoop, you can also choose to install Apache Pig, Hive, and Spark on your cluster. Now let's talk about storage. In a regular Hadoop cluster, you would store the data in HDFS. But think about where you would store your data in an EMR cluster. Remember, EMR is a use and throw cluster, meaning once you're done with the job execution, you will usually terminate the cluster. Let's say the size of the dataset you're trying to analyze is 5 terabytes. And you use this dataset for your analysis quite often against several MapReduce jobs. It would be a hassle to upload this 5 terabyte dataset to your EMR cluster every time you start a new EMR cluster. And even worse, when you terminate the cluster, the dataset will be deleted, which means you need to keep a copy of the dataset somewhere safe. Amazon S3 solves this problem. S3 stands for Simple Storage Service, and again, it is one of the services offered by Amazon. S3 provides a secure and scalable storage. You can upload your 5 terabyte dataset to S3, and then the data becomes available for your EMR cluster or any other Amazon services. The best part is the data can be shared by multiple EMR clusters. And when you terminate your EMR cluster, the data in S3 still stays. So you upload the data once and you use the dataset multiple times over and over. But there is one slight disadvantage to this approach. With S3, your data stays outside of the EMR instance. The power of Hadoop is data locality. That is to have the data and the task processing the data on the same node, so that the data is not transferred over the network. With S3, the data stays on a storage space outside of the cluster, which means the data needs to be transferred from S3 to the nodes in the EMR cluster. But Amazon guarantees faster transfers between S3 and EMR. So let's not worry about the data locality concern. The other benefit of HDFS is redundancy. The data stored in HDFS is replicated 3 times by default, which helps us recover from data loss. What about data loss with S3? According to Amazon, S3 is designed to provide 99.99999% durability of objects over a given year. For example, if you store 10,000 objects with Amazon S3, you can, on average, expect to incur a loss of a single object once every 10 million years. And that's good reliability, isn't it? So if S3 act as a storage for EMR, what is the use of HDFS that comes with Hadoop in an EMR cluster? Excellent question. HDFS in an EMR cluster is still used, and it is used for caching intermediate results during MapReduce processing. Or if you decide to keep the EMR cluster running for a longer duration, you can also choose to store data in HDFS. But you usually terminate the EMR cluster once you're done with processing. Now that we know what is EMR and S3, let's bring up an EMR cluster and execute a MapReduce job against the cluster. And this is what we will do. We will execute our stocks MapReduce program to find the maximum closing price by symbol in EMR against our stocks dataset. To do that, first we need to have our stocks dataset uploaded to S3 so the EMR cluster can access the dataset. So let's do that first. I'm logged into my AWS account, and here is the AWS homepage. You can find S3 under Storage and Content Delivery, and you can find EMR under Analytics. Let's go to S3 first. Think of buckets in S3 as folders. We'll first create a bucket and upload our dataset into the bucket. Let's click on Create Bucket, and I'm going to name the bucket HIRW Test Bucket. For the region, I'm going to choose Oregon. Region denotes an Amazon data center, so I'm going to click Create. So there you go. The HIRW test bucket is now created in S3. Storing files in S3 costs money, and based on the region you select affects the pricing. Check out the S3 pricing page before you proceed. We have selected Oregon, and I have less than a terabyte in my S3 account, and hence we will pay about 3 cents per month. But if you select Asia Pacific, for instance, you can see that you will pay slightly more. Once a bucket is created, you can add appropriate permissions and such. I'm going to leave all that the way it is. Let's go into the bucket. The bucket is now empty. Now you can click on Actions, click Upload, and you can choose your files or dataset that you would like to upload into this bucket right here. I have already uploaded the stocks dataset under HIRW Workshop under the input directory. So we're going to use this dataset for our MapReduce execution. And you can also see under the HIRW Workshop directory, I have the maximum close price MapReduce program as a jar uploaded right here. And this is the same exact jar which we used in our MapReduce chapter. There is absolutely no changes to it. Now that we have the dataset in S3, let's go to EMR, create a cluster, and execute the MapReduce program against the stocks dataset. So go to the AWS home screen, click EMR under Analytics, and click Create Cluster. Give a cluster name here. I'm going to name it HIRW Test EMR Cluster. I want to enable logging, so check the logging option. We need to provide a S3 location for the logs. So I'm going to select the logs folder under HIRW Workshop. Select that, hit select. So this is where all our logs will be stored. Now we have two options. You can bring up the cluster, keep the cluster running, and execute jobs against it, and shut down the cluster when you feel you're done. That is the cluster option. The second option is step execution, where the EMR cluster comes up, it right away executes the jobs or steps that is configured to run on the cluster, and once the execution is complete, EMR then terminates the cluster. You can choose step execution if you exactly know what you're going to execute on the cluster. For the sake of this demo, I'm going to select the cluster option. Next, we have to specify the Hadoop version. We have to either go with the distribution that is offered by Amazon or MapR. I'm going to go with Amazon and choose the latest version, which is EMR 4.1.0. Now you have to choose the list of applications that you would like to install on your EMR cluster. I'm going to choose Core Hadoop, which comes with Apache Pig and Hive, and that is all we need for our use case. Now we have to select the instance type. Remember, I was saying that EMR uses EC2 instances behind the scenes. So when you say you need 3 instances, it will start 3 EC2 instances. We do not need large instances for our use case, so I'm going to go with M1 medium instance. And I'm going to request for 3 instances. Since these are EC2 instances, you can actually log into these instances using the key pair you select right here. And here I have selected my key pair HIRW. Check out our previous lessons on cluster setup to find out how you can log into EC2 instances. Now we are ready to click Create Cluster. Now the EMR cluster is starting. We've asked for 3 instances, so it is starting one master node which does all the job coordination in your Hadoop cluster and 2 core nodes which will actually execute the task in your Hadoop cluster. Let's wait for the cluster to start completely. While the EMR cluster is starting, let's quickly go to EC2 and see what is going on there. So click EC2 and click Instances right here. And as you can see here, we have 3 brand new instances coming up. So EMR is not only starting the nodes here, but it is also installing all the Hadoop components, including Pig and Hive. So we need to give EMR a few minutes here. So once you see the starting status here turn to waiting, you know the EMR cluster is ready to use. Okay, now the cluster is in waiting status. And it took about 10 minutes for the EMR cluster to start properly, including installing all the Hadoop components. Now the cluster is ready for any MapReduce execution. And as you saw, we did not spend hours configuring a Hadoop cluster. In just 10 minutes, we are ready to run a MapReduce job in a brand new Hadoop cluster. To execute a MapReduce job, click on Add Step. Since we're going to execute a jar, select Custom Jar and give a name for the step. I'm going to call it Max Close Price Job. In the jar location, we have to select our jar. Our MapReduce program is actually stored in HRW Workshop, and here it is, right here, Max Close Price -1.0.jar. So select that and hit Select. And for the arguments, as always, you need to provide the main class. And next, you have to provide 2 more arguments, the input location, which is the location of the stocks dataset in S3, and then the output location, which is again in S3. The job will create the output folder, so make sure the output directory does not exist in S3 before you execute the job. So here are my arguments. So let's copy this and paste it in the arguments field. And finally, when the job fails, I want to cancel the job and wait. So the cluster will still be running even when there is a job failure. Now everything looks good. I'm going to say add. So if you click on steps right here, you will see our MapReduce Max Close Price job is in status pending. And in few seconds, it will change to running status. And there you go. Our MapReduce job is now running. And you can actually click on View Jobs to see the job that is running. As we can see a job that is in pending status. Soon it will be changed to the running status. And there you go. We have several mappers and several reducers, and we have 3 mappers running at the moment. So let's give a minute or so for the job to complete. So now all our mappers are completed. The reduce phase is running right now. And there you go. All our mappers and reducers are now complete. And we have executed our first MapReduce job in a brand new EMR cluster. So let's now go back to the S3 location to look at the output from the job. So I'm going to the home screen, click S3, go to the HRW Workshop directory. I see a new directory named output, so click on that. We have 3 reducers, so we have 3 files right here. So double click on one of the files. So just double clicking the file downloaded the file locally. So I'm going to open that. And here is the output, the maximum close price for each stock symbol in our stocks dataset. That is it, executing a MapReduce job in a brand new Hadoop cluster in matter of minutes, which is made possible by EMR. Beautiful, isn't it? Now once we are done, we have to make sure to shut down the EMR cluster, or we will incur charges. So to shut down the cluster, simply go to EMR, select the cluster, and just click terminate. In a couple of minutes, you will also see the EC2 instances created for this EMR cluster terminating as well. And if you're not going to use the dataset which you uploaded to S3, you should delete the dataset from S3 as well, because you will continue to incur charges as long as you have the data in S3. That is it, guys. In this lesson, we saw how to execute a MapReduce job in a brand new Hadoop cluster in a matter of minutes using Amazon EMR with a fraction of cost as compared to a traditional Hadoop cluster. I hope you can appreciate why startups would love this service. With that, let's wrap this lesson. See you in the next lesson.